This graphic gives us a good summary of the different transformations that we're going to perform on the sine and cosine graph. This one is in terms of sine, but the same things will apply if you substitute cosine right there. If there's a positive in front of the function, generally you're not going to see that, and it doesn't indicate any change at all. But if there's a negative in front of the function multiplied by the function, then that indicates a reflection, and that reflection is going to be over the x-axis. If there's a number with or without that minus sign, that indicates a change to the amplitude. The amplitude is the distance from the midline of the graph to the maximum, from the midline to the minimum. So that means that the amplitude is going to change the labels on our y-axis. A number that's multiplied by the x, either with or without parentheses in between here, is going to indicate a change to the period. The normal period for the sine and the cosine is 2 pi. To find the new period, you just take that regular period and you divide it by this number that's multiplied by x. So the new period is 2 pi divided by b. Any number that's added or subtracted to x inside a grouping right here or within the angle is going to indicate a horizontal shift. Another word for horizontal shift is a phase shift. So this is left or right. And since it's coming out of a group, then it's going to go in the opposite direction you would expect. So if I have x plus 3, it's actually moving to the left 3. If I have x minus 5, it's actually moving the graph to the right 5. And then this plus k is a completely different term. And the plus k indicates a vertical shift. So it's moving the graph up or down. Sometimes the plus k is written at the beginning of the equation, but the way you can identify it as a vertical shift is that it's a separate term. It's not multiplied, it's not part of the angle like all of this other stuff is. So we'll look at a few examples. Let's start with a simple phase shift or horizontal shift. There's nothing else going on except for this change to x inside the angle that belongs to that sign right there. So this indicates that our graph is shifting to the right pi over 3. Normally I would start the sine graph at 0, but now I'm going to shift it to the right pi over 3. From the beginning to the end of the graph is still 2 pi, so if I take pi over 3 and I add 2 pi to that, then I need to get a common denominator. So I have pi over 3 plus 6 pi over 3. That's the same thing as 2 pi. Now I can add those together and I get 7 pi over 3. So that is my ending label right there, 7 pi over 3. The entire shape of the sine graph will occur on this 2 pi length right here. Now I need the middle of those two, so I can use the midpoint formula. The midpoint formula says add the endpoints, 7 pi over 3 plus pi over 3 gives me 8 pi over 3, and then I need to divide by 2 or multiply by 1/2, which is the same thing. So if I multiply 8 pi over 3 by 1/2, I can reduce the 2 and the 8, and that gives me 4 pi over 3. There are always shortcuts that you can take. Once you get to 8 pi over 3, you know if you take half of 8, you're going to get 4. So lots of quick shortcuts you can take, but it's good to know the long version, where those shortcuts come from. If I add these two endpoints because I want the halfway point, then I get 5 pi over 3. If I multiply that by 1/2, then I get 5 pi over 6. If I add 4 pi over 3 and 7 pi over 3, that's 11 pi over 3. And if I multiply that by 1/2, I get 11 pi over 6. So these are my x-axis labels. There is no change to the amplitude, so my sine is going to reach a maximum of 1 and a minimum of -1. The x-axis is the midline for the graph here. Now I'm only graphing this over one period, so I only want to show the values for the sine between this beginning point and this end point. Sine starts at the midline, and then it reaches its highest value, its maximum, at the next critical point. At the next critical label, it's back to 0, and then to a minimum, and then back to the midline. So the sine starts at the midline and then ends at the midline. Oops, that was terrible. So then it's just a matter of connecting the dots, which is sometimes the hardest part. You want to make these curvy, whoops, and not pointy, but as long as you get that general shape, then that will be just fine. Here's an example that has several things going on. Notice that we are going to have a reflection of the cosine graph, a reflection over the x-axis. The 2 indicates a change to the amplitude. The amplitude is going to change the y-axis values. There is no vertical shift on this, so I can go ahead and say from the midline to the maximum is going to be 2, and from the midline to the minimum, we'll put my minimum at -2. Now I have a lot of things going on in the angle here. I have a 3 that's multiplied by the x, and that means that the period is going to change, and the regular period for cosine is 2 pi. If I divide that normal period by this number, then that gives me the new period. So the period of the graph is 2 pi over 3. That's how long it takes to complete the shape of the cosine. To read the phase shift or the horizontal shift, I can't just read it off of here unless I have 1 for the coefficient of the x, and I have a 3 there. So I need to factor out the 3 inside this group. If I factor a 3 out of 3x, it leaves x. If I factor a 3 out of pi, then it leaves pi divided by 3. Factoring out is just a form of division. If you multiply the 3 back through the parentheses, notice that 3 times pi over 3 will take you right back to pi. Now I know that this graph is moving pi over 3 to the left. So my beginning point is negative pi over 3. And since the period is 2 pi over 3, I'm going to add 2 pi over 3. There's 1 pi over 3, and then another pi over 3 will land me at pi over 3 right here. Now I do need halfway in between those endpoints, and that's going to be the y-axis at 0. I need halfway between these 2 points, which gives me negative pi over 6, which is just that distance, pi over 3, or adding 0 and negative pi over 3 and then multiplying by 1/2. Adding 0 and pi over 3 and then multiplying by 1/2 gives me pi over 6 right here. So each of these little segments is a pi over 6. So there's 1 pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6, which reduces to 2 pi over 3. So we know we have the correct length on the period. This cosine graph is reflected, so instead of starting high, it's going to start at its minimum. At the midline, it's going to cross and have a 0. Then it reaches the maximum, then a 0 again, and back to the minimum. Draw your curves inside here to connect the points. And that's your cosine graph. This says to graph this over 2 periods, and so we have options to do this. We could take this shape of the cosine right here, and we could repeat it over here to the right and figure out the labels that go there. We could instead repeat that shape to the left and figure out the labels. We could save ourselves a little bit of work by taking half of the period and repeating it on this side, and then take the other half and repeat it on this side. And the advantage to doing that is that I just need to find this label, and then the corresponding labels over here are just going to have negatives on them because of the symmetry of the graph. A couple of ways to find these labels. One thing you can do is, since you know that each of these segments right here is pi over 6, then this would be pi over 6, that's 2 pi over 6, which reduces to pi over 3. This would be 3 pi over 6, which reduces to pi over 2. And then this would be 4 pi over 6, which reduces to 2 pi over 3. The other thing you can do is realize that if 2 pi over 3 is your period, then half of your period is going to be 1 pi over 3. And if I start at the beginning of this new period, then add half of the full period, so I'm adding a pi over 3 to this pi over 3, then that takes me to 2 pi over 3. Now I just need to put my negative labels on this side, and I've graphed this function over 2 periods. Here's an example that has just about everything in it. Notice that this -1 is a separate term. It's totally separate from this term over here. It's not multiplied by the sine function or anything, so that indicates that this is the vertical shift. And it also means that since it's negative, that our graph is moving down 1. There's a plus in between the terms, which means that the sine graph is not reflected. The 2 is a change to the amplitude, which is going to affect the labels on my y-axis. The 4 that's in front of the x is going to change the period. the original period for sine is going to be 2 pi. And so if I divide that by 4 and then simplify, the new period is going to be pi over 2. I can't read the phase shift off of this unless I factor the 4 out of this parentheses. So if I do that, then that's going to leave x plus pi over 4 in the parentheses. Once I have a coefficient inside the group of 1 on the x term, then I can read the phase shift out of the parentheses. So this is moving left pi over 4. Okay, the place to start is to reset the midline, because we've been using the midline as the x-axis, but since we have a vertical shift down 1, we need a new midline. So we're going to dash this in. It's not part of the graph, but it certainly is helpful for sketching the graph. So pretend that that's a horizontal line, and that's our new midline. Now we want an amplitude of 2. So from the midline, we've got to count up 2, which would put us at 1, and we've got to go down 2, which would put us at -3. Those are the min and max values for our sine graph. The next thing we want to do is shift the graph to the left pi over 4. So my first label here is going to be negative pi over 4. And then the period is pi over 2 long. So pi over 2 is 2 pi over 4, as you can see right here. So if I go 1 pi over 4, I'm back to the y-axis. If I go another pi over 4, then the length of that period is pi over 2. Halfway in between is 0, so I do want to use the y-axis here. Halfway between negative pi over 4 and 0 is negative pi over 8. Halfway between 0 and pi over 4 is pi over 8. So here are my x-axis labels for one period. We'll deal with the second period after this is finished. And I think we are ready to sketch in our sine graph. The sine starts at the midline, which is why we sketch this in, because our labels are on the x-axis, but other than that, we don't want to be distracted by the x-axis. There are no points of importance that land right on the x-axis. If I go to the next critical label right here at negative pi over 8, then I know the sine graph reaches its maximum value there. At 0, we're back to the midline. At pi over 8, we're down to the minimum. And then at pi over 4, we're back to the midline. So now we connect these points. And that's one period of the graph. Since that is centered on the y-axis, it may be easier to just go ahead and extend half of the period on this side of the graph and extend the other half of the period on this half of the graph over here. Okay, we know that each of these little units is pi over 8. Pi over 4 is the same as 2 pi over 8. So our maximum right here, not the x-intercept, but the maximum right there is what we're interested in. So that's going to be 3 pi over 8. And then where the function returns to the midline, that x-axis value is going to be 4 pi over 8, which reduces to pi over 2. I can just write the negative values on the other side because of the symmetry of the graph. And I've completed the graph over 2 periods.